Hello and welcome to Otten Math. In this edition of Otten Math, we're going to cover a lot of content on sine and cosine curves and also sine and cosine equations. So objectives today: find the equations of different sine and cosine curves and to apply these equations. Right, so just some basics. We need to talk about reflections. Reflection, and we've talked about this before in transformations, is a flip of a graph over a line. And the line is called the line of reflection. Just keep that in the back of your mind. Right, so the period is the distance covered for one full cycle from start to end. I like to cover from peak to peak. Some people like to do it trough to trough. It depends on the graph that you're looking at. In this case, it's very easy to see that one full cycle from start to end is going to be equal to pi. So pi is the period. Pi is the distance on the x-axis covered for one full cycle, start to end. All right, other thing you need to know about is amplitude. Amplitude is the height of the curve over a given period. And there are two different ways to identify amplitude. For sine and cosine curves, we're going to measure it peak to median. You can also do peak to peak. So peak to peak would be the distance vertically from A to C or from C to E. But in this case, we're going to do the peak to the median. We're going to find the midline of the cyclic function, and then the distance from the midline to the peak, or either peak or trough, is going to be your amplitude. All right, so in this case, the amplitude is going to be equal to 1, peak to median. For peak to peak, it would be 2. So let's talk real quickly about peak to median. Median is the halfway point or the midline of the cyclic function. And we can figure that out by taking the peak and the trough values for y, adding them together and dividing by 2, because it's really the average value of the vertical distance, peak and trough. So y is equal to 1 plus minus 1 divided by 2. Y is equal to 0. It ends up being the median. So the distance from the peak to the median is going to be your amplitude. All right, so basic parent function, we'll get into transformed function in the next section, but today it's just the basic parent function is going to be for sine and cosine. Y is equal to A times sine B of x. Y is equal to A cosine B of x, where A cannot be 0 and B has to be greater than 0. So A can't be 0, otherwise we don't have a cosine or sine function. So a couple things that you need to know about A and B. The first is that the amplitude is going to be the absolute value of A. The sign, S-I-G-N, in front of A will tell you whether or not the graph is reflected relative to the parent function, which is A sine Bx. And then you can find the period. The period is going to be 2 pi over B, where B is this value here before x. So A amplitude, sine S-I-G-N of A tells you whether or not the graph is reflected relative to the parent function. And then the period is going to be 2 pi over B. All right, so we're going to do a little bit of classwork. I'm going to give you these simple sine or cosine functions. You're going to tell me what the amplitude is, what the period is, and if the graph is reflected relative to the parent function. So I'm going to pause here for you to finish this. All right, so the amplitude is 4. The period is 2 pi over 3, and the graph is reflected relative to the parent function. Second question, pause for a moment. Okay, the amplitude is 5. The period is 4 pi, so 2 pi over 0.5. Let's do this here. 2 pi divided by 0.5 is equal to 4 pi. And the graph is not reflected. The sign is positive, so there's no reflection relative to the parent function. All right, so now we're going to find B with a given period. Period is 5. What is B? Period 2 pi. What is B? Period is a half. What is B? I'm going to pause for a moment. All right, so period is equal to 5. B is equal to 2 pi over 5. So 2 pi over B is equal to 5. I rewrite to solve for B. I multiply B by both sides. 2 pi is equal to 5B. then divide by 5. 2 pi over 5 is equal to b. The second problem, b is equal to 1. And the last problem, 4 pi is equal to b, or b is equal to 4 pi. So 2 pi over b is equal to 1/2. Multiply both sides by b. Multiply both sides by 2. 4 pi is equal to b. All right, now we're going to find the period with the given value for b. I'm going to pause for a moment. If b is equal to 2, then the period 2 pi over 2 is equal to pi. If b is 2 pi, 2 pi over 2 pi is equal to 1 for your period. If b is 5 pi over 2, 2 pi over 5 pi over 2 is equal to 4 over 5. All right, so now we're going to do some graphing. And in terms of evaluating the graphs, we're going to create some tables first before drawing the function. And then before we get into that, I wanted to go through the process of evaluating using measures to substitute in for values of x from a table to graph the sine and cosine functions. So I'm going to say we're going to work from right to left, and let me show you what I mean by this. So I have a value as part of my x value. I'm going to substitute pi fourths in for x, and I'm going to use multiple values to create a table of outputs for y. And so when I say work right for left, I'm going to take that value for x, substitute it in here into the function, and then work to the left. So pi fourths times 2 becomes pi halves. Then I'm going to evaluate sine of pi halves. Sine of pi halves is 1. Right, so now I'm working from right to left. Sine of pi halves is 1, and then 2 times 1 is equal to 2, and that's the value you're going to put into your table. Right, so you're going to create these tables, and then we're going to take a look at the function. So I'm going to pause here, create your table. Probably better that you complete in increments of pi 6, but in this case I did it in increments of pi fourths. So I'm going to pause. Right, you can take a look at your table and the graph. Now we're going to graph the function, so that's what I want you to do. You can make sure that your answers are correct here. You're going to create a graph that looks something like this, and then plot both the sine x curve and the 2 sine x curve. I'm going to pause here while you do that. All right, so here's the sine x parent function, and 2 sine x is I'll say the translated function. And sine x versus 2 sine x, you can see that the amplitude in this case changes. So as we saw before, this value here corresponded to the amplitude deviation for the median. The median is still the same for both functions, but now the amplitude has changed from 1 to 2. All right, so now let's do y is equal to sine 2x versus y is equal to sine x. Again, I suggest you do it in increments of pi 6, but I've done it here in increments of pi 4, so I'll pause for a moment. All right, so here are your table of values. You can check your answers. I'm going to pause for a moment. You can create the graphs for both. So you're going to graph on a graph with the axis that looks like this. I'm going to pause while you create your graph. Sine x, parent function, to sine 2x. Now what's changed is that the graph has, between sine x to sine 2x, the graph has been compressed by a factor of 2. Right? So we had previously had sine x, the period was 2 pi, and here b is equal to 2, so 2 pi over 2, now my period is equal to pi. Right? So my period has been compressed by a factor of 2, and the b value will tell you whether or not it's been compressed or expanded. If the value is greater than 1, we're compressing. If it's less than 1, then we're expanding the function. Right, so now I want you to fill in the tables for y is equal to negative sine x versus sine x. Pause here. Right, so you should get these values. Now you're going to graph the function. And now you can see that sine x versus negative sine x, the amplitude stays the same, the period stays the same, but the graph is reflected now over the x-axis. All right, last function, y is equal to negative 4 sine 3x. Again, I suggest you do this in increments of pi sixths. I've done it in increments of pi fourths, but it's going to work out better if you do it in increments of pi sixths. Here you can see I've changed the table. Started to fill it out. This is good enough for you for now. To go to 2 pi thirds, you can complete the rest of the table if you want. Pause while you graph. And here's the prior table with the pi fourths. All right, so we graph the function y is equal to negative 4 sine 3x. My amplitude now has changed to 4. Median is still y is equal to 0. My period is 2 pi over b, 2 pi over 3. So you can see my period from start to end, and I'm measuring it now at the midline to go from midline to midline, or start to end, is going to be 2 pi over 3. And then the graph is reflected relative to the parent function, which is y is equal to sine x. All right, so again, another look at this. My period is going to be 2 pi over 3, amplitude of 4. Another graphical representation of the same function. All right, so now we're going to create an equation based on some information, then we're going to solve some equations. So what is the equation of a sine function that varies between, or has a maximum of 9 and a minimum of negative 9 with a period of 5? All right, so we know in this case that the midline is going to be y is equal to 0. 9 plus negative 9 is 0. 9 plus negative 9 divided by 2 is 0. So my median is going to be y is equal to 0. My amplitude is going to be the distance from the median to the peak. Either direction is going to be equal to 9. My period is going to be equal to 5. So 2 pi over b is equal to 5. B now is equal to 2 pi over 5. So I can write my equation as plus or minus 9, which is the amplitude, times sine bx, which is 2 pi over 5x. All right, so let's move on and solve some equations. Solve 2 sine x is equal to 1. So there are two parts to this. The first part is to divide both sides by 2. Sine x is equal to 1/2. And then I'm going to solve for x. I take the inverse sine of 1/2 is equal to x. And then in degrees, I have to provide both answers, 30 degrees and 150 degrees. I should tell you that the x value needs to be between 0 and 360 degrees for this. So I'm defining the domain. Solve 2 sine 2x. Again, we're going to divide both sides by, I'll pause for a moment while you work this out. We're going to divide both sides by 2. Sine 2x is equal to 1/2. Take the inverse sine of 1/2 is equal to 2x. Now there's another step here, because I get the same value of 30, but 30 now is equal to 2x. X is equal to 15. That's going to be my reference angle. And I also know that that value for x, sine of 1/2 is equal to, inverse sine of 1/2 is equal to 30 or 150 degrees. So I need to estimate or value what the value of x, is for 150 degrees, and I find that x is equal to 75. So your values for x in this case are both 15 and 75. So here you want to provide both possible values for inverse sine of 1/2 before you solve for x, so you get the correct values for x ultimately. Right, another equation, 2 sine x over 2 is equal to 1. I'll pause while you work this out. Right, so again, we're going to divide by 2. Sine x over 2 is equal to 1/2. Take the inverse sine of 1/2. Again, it's 30 degrees and 150 degrees. Equal to x over 2. Solve for x. X is equal to 60 or 300 degrees. And again, I should define the domain in this case for x. Last one, 6 sine 3x is equal to negative 3. I'll pause for a moment while you work this out. All right, so I'm going to divide both sides by 6. I get sine 3x is equal to negative 1/2. Inverse sine of 1/2 is equal to 3x. 330 degrees is equal to 3x. X is equal to 110 or x is equal to 70.